Today's lesson is on adding and subtracting rational expressions. Now, because a rational expression is really just a fraction, you do it the exact same way you would add or subtract fractions, meaning that in order to do that, you would have to have common denominators. An example of that is if I were trying to add 3/4 plus 2/8, I can't add this because they have different denominators. In order to do that, I would have to use what I know about equivalent fractions to come up with a fraction that is equivalent to 3/4 that would be in eighths instead of in quarters. Now, I know from previous math that in order to make an equivalent fraction, whatever I multiply the denominator by, I have to multiply the numerator by the same thing. Okay? When I do that, I find that 6/8 is equivalent to 3/4. So really, now I can add, because I have common denominators. I would add 6/8 plus 2/8, and I'd end up with 8/8. It's the exact same principle when you are adding and subtracting rational expressions. Okay, so the steps are outlined for us here again. Let's mark them, highlight them. It's really very straightforward. We're going to, again, factor the numerator and denominator as necessary, if it's needed, in other words. Then we're going to state the non-permissible values for the exponent, the values that would make that denominator equal to 0, because we can never have a denominator in a fraction that is 0. Then we're going to find a common denominator if the two rational expressions that we're adding have different denominators. Then we're going to make equivalent expressions, just like using what we know about equivalent fractions to come up with an equivalent fraction. We're not changing the value of the fraction, just coming up with one that is equivalent. And then we're going to add or subtract as indicated. And what that means is we're going to add or subtract the numerators, but the denominator remains the same. Just like when you add fractions. When we were adding that 6/8 plus 2/8, it ended up being 8/8, right? We're just adding our numerators. Our denominators don't change. That's all that's saying. And then, of course, the last step is we always list our answers in the simplified form. Okay, so let's give this a try. We've got a couple here to try. The first example is x over 3 plus 4x over 3. Now, when I look at this one right away, I notice that they already have a common denominator. They're both over the denominator of 3, which means I really just can add straight across the numerator. So I've got x plus 4x, that equals 5x,
to the office, please.
and it's all over 3. There is no non-permissible values that I have to worry about because there are no variables in either of my denominators. Okay. The second example, again, I see that I have common denominators, so I know I can add. Again, I just add straight across the numerator, so 5 plus 2 is 7, and my denominator stays the same. It's all over 3x. Okay. Now, in this case, there is a non-permissible value for x because we do have a variable in the denominators, so my x on either of those denominators cannot equal 0. And I have to state that as part of my answer. Okay, moving on to the next example, I've got 3 over x squared plus 5 over x squared minus 2 over x squared. Okay, it's the exact same thing. My denominators are all the same, so I can just add and subtract straight across the numerator. So I've got 3 plus 5, which is 8, minus 2, which is 6, all over x squared. Now, my x cannot equal 0, or else it would give me a denominator of 0. So that is part of my answer, the non-permissible value of x. Okay, and in this fourth example, I've got x squared plus 1 plus 2x squared plus 1, and those are both over denominators of x squared. So again, they've made this so easy for me by giving me a common denominator. So I can just add straight across. I've got x squared plus 2x squared, that's 3x squared, 1 plus 1, which is 2, and that's over the common denominator of x squared. Now, can I simplify this any further? Remember yesterday we were talking, or on Friday I guess, we were talking about how some people look at this and think this x squared will cancel out this x squared, but it won't, because this whole amount up here is one whole value. It is together. So this x squared would have to be in this term as well as in this term in order for us to cancel it out, and it's not. Okay, so we leave it exactly as it is. This is the most simplified form, 3x squared plus 2 over x squared. But we do have to list what our non-permissible values for x would be. Our x, again, cannot be equal to 0, or it will give us a denominator that is equal to 0. That's our final answer. Okay, the first few examples have been very simple and straightforward because they've already had common denominators. The next few examples also have common denominators, but this time instead of just being a single digit, our denominator is a binomial, n plus 3. Okay, but we have the same denominator on both rational expressions. So it's just the exact same as before. We have a common denominator, and that's n plus 3. So we can just add or subtract straight across the numerator. So I've got n plus n, that's 2n. And I've got positive 1 plus negative 1, that's nothing. So I actually don't even have to write that. So it really, my answer is 2n over n plus 3. My non-permissible value of n is that n cannot equal negative 3. If I set n plus 3 not equal to 0 and solve for n, I get that n can't be negative 3. That's how I got that. In either case, in either denominator. Okay, this question I have, again, common denominator of x plus 2. So this is very simple. I'm just going to move this recording button out of the way so that I have a little more space to write here. I have a common denominator of x plus 2. The numerator is a little bit different though, because I have 4x minus 1, but then I have this minus this whole amount, right? This is one whole value. So I need to apply that negative 1, really, to this term. I have to multiply it by that term, and I have to remember to multiply it by that term. That's called distributing the negative. So I have to multiply negative 1 times x, which is negative x, and negative 1 times 3, which is negative 3. Okay, now I'm going to collect like terms. So I have 4x minus x, so that's 3x, and I have negative 1 minus 3 is negative 4. That's all over the common denominator, which was x plus 2. My non-permissible values of x are that x cannot equal negative 2. That's my final answer. Okay, moving along to the next example. I now have some denominators that are different. And this is where I'm going to have to make sure that I have common denominators before I can do the adding or the subtracting part. When I look at the denominators in this question, I've got 9, 3, and 6. I'm looking for a common denominator, a number that 9 would multiply to, 3 would also multiply to it, and 6 would also multiply to it. The common denominator would be 18 then, wouldn't it? Okay, so what I'm really going to do is figure out what I would have to multiply that denominator by to equal 18, and then I have to do the same thing to the numerator. So this 9, to get 18, I would have had to times by 2. So I'm going to do the same thing to this 4x on top. 4x times 2 would be 8x. Then for this middle term, I have right now a denominator of 3, and I have to decide or figure out what I multiplied that by to get 18. So 3 times 6 will get me 18. So I do the same thing to the numerator. 2 times 6 would give me 12. Thanks. Same thing with this last denominator of 6. In order to make it a denominator of 18, I multiply by 3. So I'm going to multiply the numerator by 3. 5 times 3 is 15. X. Okay, now that I have common denominators in all 3 of these rational expressions, I can just add and subtract the numerators and put them all over the common denominator of 18. Okay, so I've got 8x minus 12x, that's negative 4x, plus 15 is going to be 11x in the numerator. Now, are there any non-permissible values in this question? No, there are not, because there is no variable in the denominator. So this is all I would have to list as my answer. Okay, I'm going to show you another way, which really is what we did in this previous question. But now that our numerator in the next example is a binomial, it's made of 2 terms, k minus 7 or k plus 2, I'm going to show you how we would make a common denominator. Okay, so right now when I'm looking at my 2 denominators, I see a 4 and a 5. And I think to myself, what would be the lowest common denominator that would have both a 4 multiply into it and a 5 multiply into it? Well, I go through 4 times 2, 4 times 3, 4 times 4, 4 times 5, until I find one that both 4 would go into and 5 would go into. And the lowest common denominator I can come up with would be a denominator of 20. Okay. Now, in order to get a denominator of 20 on this side, what would I have multiplied this 4 by to get 20? I've multiplied it by 5. Okay, I'm going to need to do the same thing on the top, multiply by 5. But when I do that, I have to remember that I'm multiplying both the k by 5 and the negative 7 by 5. Okay, so really what I'm doing is multiplying the numerator by 5 and the denominator by 5. Okay. I can write that this way. I'm multiplying the numerator by 5 and the denominator by 5. This is a fraction, 5 over 5. And 5 over 5 actually equals 1, right? Whenever you have the same number in the numerator and the denominator, it's equal to 1. So when I'm multiplying this side of the equation by 1, I'm really not changing the value of that equation at all, right? I'm just multiplying it by 1. It's just that this 1 just happens to be the numbers that I need in order to make a common denominator of 20, right? 4 times 5 will give me 20. Okay, I'm going to do the same thing on this side now. I'm going to figure out what do I need to multiply this side by to give me a common denominator of 20. Well, think in your head for a minute. What would I have to multiply that 5 by to give me 20? I'm multiplying by 4. So I'm going to do the same thing on the top. I'm going to multiply by 4. So in essence, I'm multiplying the numerator by 4, the denominator by 4, which really means I'm multiplying the numerator by 4, the denominator by 4. Oh, look at that. 4 over 4 is also equal to 1. So I'm multiplying this side of the equation by 1, which means I'm really not changing the value of it. Anything times 1 is still itself, right? So this side of the equation I'm multiplying by 5 over 5, equivalent to 1. This side of the equation I'm multiplying by 4 over 4, also equivalent to 1. So I'm really not changing the value of the equation at all. I'm just multiplying by something that's going to give me a common denominator of 20 in both rational expressions. Okay? Now, what I said a minute ago, though, is when I multiply 5 times k minus 7, I'm multiplying 5 times k and 5 times negative 7, right? Same thing on this side. When I multiply 4, I multiply it by the k, and I multiply it by the 2. Okay? So I have to remember to distribute that 5 and that 4 by both terms in the binomial. Okay, so 5 times k is 5k. 5 times negative 7 is negative 35. Oh, you know what? I'm going to leave this minus sign in the middle. And so I'm going to keep this stuff all together as one value on one side. Okay, and we're going to see what this would be. 4 times k would be 4k. And 4 times 2 would be 8. And this is all going to be over a common denominator of 5 times 4 or 4 times 5. That's 20, isn't it? Okay. Now, do you see why I bracketed after this negative sign here? Because I have to remember that that negative sign in the middle really means I'm multiplying negative 1 times whatever I have in the numerator here, this k plus 2 that I'm multiplying by 4. That negative 1 means negative 1 times everything that is on the right side. Okay? So again, I have to remember to distribute this negative 1 times that and times that. Okay? So to simplify this now, let's write it one more time. I have 5k minus 35. I really would have minus 4k minus 8 all over 20. Now I'm going to combine like terms, do my subtraction. I've got 5k minus 4k. That gives me 1k. I just have to write it as k because the 1 is assumed. And then negative 35 minus 8, which is negative 43. And that's all over the common denominator of 20. This is my final answer. Are there any non-permissible values? No, there are not, because I don't have any variables in my denominator that I have to worry about. Okay, so let's try the next example then. We have a 4 and an 8 and a 6 in the denominator. Okay, so I'm looking for a common denominator. The lowest common denominator that all three of those factors, or all three of those would be factors of, would be 24. Okay, so what do I have to multiply 4 by to get 24? 6, right? So I'm going to multiply this part of the equation by 6 over 6. Okay, do you see how 4 times 6 in the denominator here is going to give me 24, right? But whatever I multiply the denominator by, I have to multiply the numerator by the same. That's how I have 6 over 6. Okay. Same thing here. I need to ask myself, what do I have to multiply that 8 by in the denominator to get 24 in the denominator? Well, I'm having to multiply it by 3 over 3, right? Because 8 times 3 is going to give me 24 in the denominator. Okay? And 3 over 3 is just 1. I'm just multiplying by 1. Then over here, what do I have to multiply the 6 by to get 24 in the denominator? 4. And whatever I multiply the denominator by, I have to multiply the numerator by. Okay? So I figured out what I'm going to have to multiply by in order to get a common denominator now of 24. Okay? So I'm going to multiply 6 times both the 3x and the 2. So 6 times 3 is 18x. And now 6 times 2 will give me 12. So I've got 18x plus 12 over 24. Plus, now I'm going to multiply this 3 over 3. I'm going to just rewrite that so that it's I don't cover up this minus sign. So I'm multiplying this side by 3 over 3. Okay? And I have to remember to multiply that by both the x and the negative 4. So I've got 3 times x, which is 3x. And I've got 3 times negative 4, which is negative 12. And that's all over a denominator of 24. And then I'm subtracting, and let's multiply 4 by both the 2x and the negative 1. So 4 times 2x is 8x. And 4 times negative 1 is negative 4. Now don't forget, because you have this minus sign right here, this is very important. It means we're subtracting this whole amount there. So put a bracket around that so that you remember to multiply negative 1 times the 8 and negative 1 times that negative 4. That's going to change some signs. And that's all going to be over 20, a common denominator of 24. Okay, now that I have common denominator of 24, I can just go ahead and rewrite the whole numerator all together in one big long strip and put it all over a common denominator of 24. So I've got 18x plus 12 plus 3x minus 12. Then I have this negative sign. Negative 1 times 8x is negative 8x. And I've got negative 1 times negative 4, which is positive 4. And that whole big long numerator can be put over the denominator 24, the common denominator we made. Okay, now let's combine like terms. So I've got 18x plus 3x, that's 21x, minus 8 is 13x. Now I'm going to combine my constants. I've got positive 12 minus 12, so that's 0, plus 4, which is positive 4. And that's all over the common denominator of 24. Are there any non-permissible values in our denominator? No, because we don't have any variables in this denominator. Okay, the next question, I've got a denominator of 3x and a denominator of 2x. Well, my least common denominator that both 3x would multiply into and 2x would multiply into is going to be 6x. Okay, so what would I have to multiply this denominator by to get 6x? Right, 2. So I'm going to multiply the numerator by the same thing, 2 over 2. So then I'm just multiplying really by 1, right? And it doesn't change the value, the amount. Okay, same thing on this side. What would I have to multiply the denominator by to get 6x? 3, right? 2 times 3 would give me 6, and then the x. So on the top, I'm going to multiply this by the same thing. Whatever I do to the denominator, I have to do to the numerator. Okay, so I've got 3 over 3 that I'm multiplying that side by. Okay, now I'm going to multiply straight across. So on the top, I've got 10. In the denominator, I've got 2 times 3x, which is 6x. My other term, I've got 1 times 3 in the numerator. That's 3. 2x times 3 is 6x in the denominator. So I've got common denominators now. So now I can add straight across the numerator. That's 10 plus 3, which is 13, all over the common denominator of 6x. Now this time I do have a non-permissible value of x, and that is that x cannot be equal to 0. So I have to list that with my answer. That's part of my answer. Okay, moving along to the last two examples on this page. We've got a denominator of 8y, 6y, and 4y. The least common denominator has to be something that 8 and 6 and 4 will all multiply to. So the least common denominator I can think of would be 24, because 8 times 2 would be 16. They don't all go into that. 8 times 3 would give me 24, and all 3 go into 24. Okay, so what would I have to multiply my 8 by to give 24 in the denominator? 3. 8 times 3 is 24. So I'm going to multiply the numerator also by 3. Okay, what am I having to multiply my 6 by to get 24? Right, 4. So I'm multiplying this middle term by 4 and over 4, because I'm doing the same thing to the top as I do to the bottom. Okay, and then the same thing here. What would I have to multiply my 4 by to get 24? 6, right? So I have to make sure I multiply the top by 6. Okay, so now let's multiply it out. I've got 3 times 3 in the numerator here, so that's 9 over my denominator of 24. 3 times 8 is 24. Y. Minus, I've got a 5 in the numerator times 4, which is 20. And in the denominator, I've got 6y times 4. That's 24y. Then I've got plus 1 times 6 in the numerator, which is 6, over 4y times 6, which is 24y. Okay, you can see that all three terms have a common denominator of 24y. So now I can actually just add and subtract straight across. I can write it out as 9 minus 20 plus 6 all over 24y. Or I can skip that step and I can just do it in my head. 9 minus 20 is negative 11 plus 6 is negative 5 over the common denominator 24y. What are my non-permissible values for y? Well, y, if I go back to my original question, y cannot be 0 in any of these three cases, or else it would give the denominator of the rational expression as 0 in the denominator as the denominator. And we can't have 0 denominators. So y cannot be equal to 0. Okay, the next question has a 3x as one denominator and a 2x on the other side as a denominator. I know right away my least common denominator is going to be 6x. So on this side, to make my denominator 6x, I have to multiply by 2. So I'm going to multiply my numerator also by 2. Okay, on this side, I can see that in order to make this denominator 6, I would have to multiply that 2x by 3. 2x times 3 is 6. So I'm going to do the same thing on the top, multiply the numerator by 3. So that I'm not changing the value of the equation, I'm just multiplying really, in essence, by 1. But it's the form of 1 that's going to give me a denominator of 6x. Okay? So now I have to multiply 2, and when I multiply it, in the numerator I have to remember to multiply the x and the 2, both by 2. So 2 times x is 2x, 2 times 2 is 4, and that's going to be all over the common denominator of 6x, plus, same thing on this side, I have to multiply by the 3 by 2x, which is 6x, and the 3 by negative 5, which is negative 15, all over the denominator 6x. Now I have common denominators, so I can just add straight across and subtract straight across. So I've got 2x plus 4 plus 6x minus 15, all over the common denominator of 6x. When I combine like terms, I've got 2x plus 6x, that's 8x. 4 minus 15 is negative 11, and that's all over 6x. My non-permissible value for x, look back here at your equations up here. X cannot be equal to 0, or it will give me a denominator equal to 0. All right, we have 2 more examples to go through at the top of the next page, and then you're going to get a chance to practice a few of these and try them for yourselves. Okay, the first one, I have a denominator of 3n on one side and a denominator of 9m on the other side. Okay, well, remember that the least common denominator has to be one that both 3n and 9m will multiply into. So it's going to have an m in it and an n in it, and it's going to have or be a multiple of 3 and 9. Okay, so 9 would work. 9mn would work because I have to have one that both the m and the n will divide into. Okay, so on this side, if I wanted to have a common denominator of 9mn, what am I going to have to divide this denominator by to get 9mn? Well, first I'd have to multiply the 3 by 3. That would give me 9. I've already got the n, so I'd have to multiply by an m, right? So if I multiply 3m times 3n, I'm going to have 9mn, right? Okay, now remember the same thing that you do to the denominator, you have to multiply the numerator by. So that's going to be 3m as well. Do you see how 3m over 3m is really just 1, right? It's the same number in the numerator as the denominator, so it's equal to 1. Even though there's a variable in it, it doesn't change. Okay, on this side, what am I going to have to multiply the 9m by to get a denominator of 9mn? Right, just an n, right? Same thing on the top, then I have to multiply the top by just an n. And when I do that, I'm going to have a denominator of 9mn, right? Okay, so now we can multiply across. I have 3m on top times 5m. Well, that's 15m squared. And the denominator is going to be 3m times 3n. 3 times 3 is 9mn. Then plus, in the numerator on the other side, I have 4n times n. So that's 4n squared. And on the denominator, I've got 9m times n. That's 9mn. Oh, look at that. I have common denominators now. So I know that that means I can just add the numerators. 5m squared plus 4n squared all over the common denominator 9mn. Now, are there some non-permissible values in my denominator? If you look back here at your original question, we had 3n. So n cannot equal 0, or it's going to give me a denominator of 3 times 0, which is 0. Okay, on this side, I have to look at what the m can't be as well. M can't be equal to 0 either, because if it was, then I'd have 9 times 0, which would give me a denominator of 0. All right, last question. I have a denominator of 5x, a denominator of 2x squared, and a denominator of x cubed. Okay, well, first of all, I need a number that my 5, my 2, and there's really a 1 assumed right here, isn't there? Okay, so that 5, 2, and 1 will all multiply into. Well, the lowest number they will all multiply into is going to be 10. Okay, so what would I have to multiply this denominator by to get 10?
Cage, Karen to the office, please. Cage to the office.
Okay. Now, I also need to look at the x's, because I've got an x squared, and an x cubed. So I'm going to need something that x will multiply into, x squared will multiply into, and x cubed will multiply into. They will all multiply into x cubed. But since I've already got one x here, I just would have to multiply it by x squared to get x cubed altogether, right? Because I'm going to have an x cubed as my common denominator. My common denominator is going to have to be 10x cubed. That's what I'm shooting for, okay? Because it has to be a number that the 5, the 2, and the 1 will all multiply into. That's the 10. And the x squared, and the x cubed will all multiply into x cubed, okay? So 2x squared on the bottom is what I'm multiplying by, so I have to multiply by the same thing on the top, 2x squared. 2x squared over 2x squared is really just 1, yeah. Okay, middle term, I've got 2x squared as my denominator. What do I have to multiply it by to get 10x cubed? Okay, well, I'm going to have to multiply it by a 5. And I need one more x, right? So 5x. So on the top, I have to multiply by 5x. So it's 5x over 5x, which is 1. Same thing with this last term. I need something that I need to multiply this x cubed by that will give me 10x cubed. Well, that's 10, right? 10 times x cubed is going to give me 10x cubed. So whatever I multiply the bottom by, I have to multiply the top by. 10 over 10 is equal to 1. Okay, so let's multiply this out now. I've got 2x squared times 4, which is 8x squared. On the numerator, in the denominator, I've got 5x times 2x squared, which is 10x cubed. Okay, then I have a minus sign. Now I'm multiplying 3 times 5x, which is 15x. And in the denominator, I've got 2x squared times 5x, which is 10x cubed. Then I have plus 1 times 10, which is 10. And in the denominator, I've got 10 times x cubed, which is 10x cubed. And there I can see that I've made all three of those rational expressions have a common denominator of 10x cubed. Okay, so now I can just write all of my numerator together in the all of my terms together in the numerator. 8x squared minus 15x plus 10, and that's all over the common denominator of 10x cubed. Now, what is the non-permissible value for x? Well, x cannot be equal to, look back in your original equations here, what could x not be? Or else it would yield a denominator of 0. X cannot be equal to 0. Yeah. Okay, so this gives you a good practice, a beginning practice of adding and subtracting rational expressions. We haven't gotten into any yet that we've had to factor. They've been quite nice to us with giving us just single term, for the most part, in our denominators. Some binomials, but mostly monomials. So it's been quite nice. We haven't had to do any factoring. In this assignment, it will give you some practice making common denominators. Please do check your answers, though, with my website so that you can make sure that you're on the right track. And if you have questions or problems, you can maybe see where you made a mistake. And please come and see me during Flex or ask Mrs. Vardstra if you need extra help. Okay? Please try this assignment in your book. It's on page 23, 24, and 25. And just the very, very top of 26.